Hi, everyone. Welcome to Being Patient Brain Talks. I'm Deborah Kan, founder of Being Patient. Well, we're going to talk about a topic today that impacts all of us, and that is sleep and the quality of your sleep. Joining us is Laura Lewis. She is a researcher, a sleep researcher at Boston University. She's done many studies on sleep, and including a recent one on how deep sleep impacts the brain and can it really clear plaque from your brain, which of course we know could lead to the road to Alzheimer's. So Laura, thanks very much for joining us.
Thank you for having me. It's great to talk with you.
So let's just start first with understanding. I mean, I know there's been, I have a tracker now and I'm obsessive about tracking my sleep, how much deep sleep I need to get, REM, etc. Tell us, what should we be worried about? Light sleep, deep sleep, REM, what is the most crucial in terms of brain health?
Oh, so that's actually kind of a tough question because especially as a sort of sleep professional, I think all parts of sleep are important. One thing I do like to mention at the beginning is I'm not a medical doctor, so I don't give clinical advice on how to sleep. But there's many different stages of sleep, and each of them seems to be important in a different way. So it's not necessarily that one of them is the most important, but that they each serve a different purpose, maybe for the brain.
Okay, so tell us a little bit about what I mean, I know you've now done a number of studies on sleep, but talk us through the progression of what you've learned.
Sure, yeah. I think, our most recent study is maybe the one that's very interesting for this community, which is we wanted to understand, what might be happening in the fluids in the brain during sleep. And so the reason that we wanted to know this is there had been a lot of previous, fascinating work showing that sleep is really critical for brain health and that disrupted sleep seems to be associated with neurodegenerative disease. And groups like Mike and Nadergaard's group and David Holtzman's group have shown that sleep is also important for the levels of toxic proteins such as amyloid beta in the brain. So we wanted to understand why it might be that sleep is such an unusual state for these kinds of dynamics. And so our study used brain imaging to look at what's happening in cerebrospinal fluid in the brain during sleep. And that's a liquid that envelops the brain. It cushions it. It's important for things like waste clearance from the brain. And so we ended up having people come into the lab at midnight or so and getting brain scans while they were sleeping. And what we saw is that when people would fall asleep, we would actually see these large waves of fluid that seemed to kind of wash through the brain. And so that was really fascinating to us, just the fact that there are waves of fluid in the brain that during sleep. That alone was a kind of interesting observation. We also went on to image different aspects of brain function, and we realized that a specific pattern of electrical activity that happens in the brain during sleep, it's followed by a wave of blood oxygenation and then the wave of fluid. So it seems that all of these things are coupled together. And so, we're very intrigued to understand what these waves of fluid might actually mean and their consequences for brain health.
Okay, so just to put it into layman's terms, the way that I've understood it, someone like I'm going to use non-scientific vocabulary, is, we sleep and that's when our brain really associates new learning with old learning. And then on top of it, something called the microglia come out, which are the janitors of our brain that kind of sweep away all of the bad stuff while we're sleeping. So when you're talking about the cerebrospinal fluid,
Mm-hmm.
is that where our microglia is? Is this what you're tracking?
So what we're measuring is on a very different scale than what's been measured before. And so, like you say, there's been lots of fascinating studies looking at the microscale. So what's happening in individual cells, what's happening in the fluid between cells. And if you think about the way waste would need to leave the brain, it would need to come out of the tissue and it would eventually need to kind of exit that and make it through this space and actually kind of be drained away. And so work in animals has been done really interesting things to look at these kind of microstructures. And our study focused sort of on a different spatial scale. So the cerebrospinal fluid dynamics that we measure, it actually is sort of all around the brain, kind of enveloping it. And So you can think about it as that, anything that was eventually kind of making its way out of brain tissue would make it into this fluid. Now, we didn't measure those, those things making their way out. We sort of measured the fluid itself, and it's kind of pulsing around the brain, if that makes sense.
So does the amount of sleep you get, is that directly correlated to the amount of fluid that's in the brain?
So it wasn't actually the amount of fluid, but it was how fast it was flowing. So what we found is that when people were sleeping, it started to flow in these large waves. And so when they're awake, your fluid is always pulsing a little bit as you breathe or as your heart beats. But then when you fall asleep, it starts to kind of gush in waves.
About washing away that toxic substance. I mean, can you actually see within the fluid that the plaque is actually coming out, or how do you determine that?
No, yeah. So in our study, we're not measuring that. And I know that everyone's really interested in that, and we're very interested in that, but that was not something we measured in this study. So the reason we were curious about why this fluid might be moving was because of previous studies by people who were using mice, for example, and they would actually kind of attach a tracer and watch these things be cleared directly. And our study doesn't do that. What it did was try and understand why might things be being cleared differently in sleep. But because we were imaging non-invasively in humans, we couldn't track the proteins themselves. We're just watching the fluid. So I'm very interested to do follow-up studies now where we try and kind of think of a different way to do these measurements, where potentially we could measure both of these things at the same time.
So how does this all relate, though, to the microglia, taking it back to the microglia? Microglia, as I understand it, microglia come out at a particular time of sleep. So the quality of sleep means that's better for our brains. I think that's already been established, right?
So definitely good sleep is good for your brain.
It's good for a lot of things. It's good for your sanity. It's good for your parenting. It's good for a lot of things.
General happiness.
Yes. But I guess that what you're trying to determine is, are we actually extracting the beta amyloid plaque? Is it a cleansing process, and if you indicate that it is, then that would actually prove that there's a link between the quality of sleep and your risk for dementia. Is that right?
So I think it's a really interesting question. I think the way that I would think of it is that these may be things happening at different stages. It may be that microglia are sort of, working away inside the tissue. And then as things are exiting the tissue, they also need a path to exit. If that's sort of the best analogy I can come up with that. One would sort of, work in the brain, and the other would be the kind of river flowing away from it, is the way I would put it. In terms of the link with dementia, I think it is pretty well established now that, sleep really is altered in patients with dementia, and the actual kinds of aspects of sleep that are altered are the same ones that we saw were associated with these flow waves in our study. So that's part of, our study was entirely in healthy young adults. So, we wanted to understand what's happening normally in kind of youthful, typical brains in the sort of 20s and 30s. And so, our study would predict that if you did the same imaging in patients with dementia, you would see less of that flow. But that's exactly what we want to actually do now in a follow-up study, is check whether that prediction is true.
So when you looked at the healthy, the participants who are healthy in their 20s and 30s, were you able to determine what a normal flow of these toxins would be? I mean, is there a way to kind of say, okay, we know that sleep is eliminating X percentage of toxins in our brain?
So I would say from this study, no. Yeah, we didn't measure sort of toxins or protein clearance directly in this study. What we are able to see is kind of how rapidly and how often you see these flow waves. And so I think that there's a sort of critical next study to be done, where you measure these waves and then you also directly measure, whatever kind of waste product you would want to track at the same time. So maybe that's amyloid, maybe it's something else. And I think that will be critical to have that next study to actually start to answer the question that you asked, which I just can't answer yet, unfortunately.
So do we know, I mean, this is kind of a little bit of a tangent, but it does come up because as we know, people with dementia suffer from a disruption in their sleep patterns, commonly. We always see the comment, well, is it okay to take a sleep aid? And recently on Being Patient, we had the FDA just recently approved a sleep drug for dementia patients. But is that real sleep or is that mimicking sleep? Do we know, is sleep just sleep, or if it's aided by medication, is that actually changing the process of what naturally occurs in our brain?
Yeah, that's such an important question. Different sleep drugs are different. And so they have different mechanisms of action, and they will often sort of mimic different aspects of sleep. One might look more like the normal electrical brain activity. One might look more kind of behaviorally what we typically see. In terms of what it means for this process, since we just discovered it, we don't know yet what happens with various medications. And I really would like to do that study now as well. I think it's a very important question that I would love to investigate. In the meantime, I think, people's physicians are the best recommenders of whether they should be taking those or not.
So what's the next, so you said you're moving on to people with dementia in your next study. Tell us a little bit about the scope of that study and exactly what you will be measuring.
Yeah, so firstly, we want to understand how are these waves affected? How are they affected in healthy aging? Because a lot of things change in the brain in healthy aging that aren't related to dementia. And so it's important to not just study people with dementia, but also to study people who are kind of the same age, but are aging healthily, and to understand what the difference is there. So that's going to be a critical piece of it. And then the other is we'd like to develop a more kind of, we'd like to add a measure of exactly what you're interested in, actually measuring some kind of protein in the brain at the same time, and not just measuring the fluid flow, because it's going to be very important to know, whether and how those two things are related.
To be clear, I mean, we all have a certain amount of beta amyloid in our brains. It's just when things go wrong and they overproduce, that's what leads to dementia, or presumably leads to dementia. Is that right?
So there's, of course, a lot of research trying to understand exactly what leads to dementia. And so the exact kind of thing that's the cause, of course, is what we would all like to know for sure. But one of the kind of diagnostic factors for something like Alzheimer's is that you see that there's aggregation of these things like amyloid, that they're sort of, they're sort of building up in the brain.
Did you see more fluid in the healthy studies? Did you see more fluid in different stages of sleep? In particular stages like deep sleep or REM or whatever?
That's a great question. So what we saw, we actually didn't study REM sleep. So we still don't know if this happens in REM sleep or not. Most of our data was in a substage of non-REM called N2 sleep, and that's kind of like an intermediate sleep. And we saw a lot of these waves in this kind of intermediate stage of sleep. We also looked at lighter sleep, the kind of sleep you have very early in the night for, actually a much smaller amount of time. And we didn't see much of these. It's possible there's a little bit that we couldn't tell, but definitely once people went into this intermediate N2 stage, then we saw a lot of the waves. It will be very interesting for us to check REM sleep as well, and to also, investigate the deepest stages more as well.
So this study didn't include deep sleep?
Very little, actually. Most of it was intermediate. It did include some deep sleep, but the majority of the data was intermediate stage.
Okay. And why did you focus on the intermediate versus REM versus, what was it about that stage in particular?
Yeah, it's kind of, it's sort of reflecting just how challenging it is to do these experiments. So the reason, in part that people haven't done any of these is it's just very difficult to image the brain with all of these different things while someone is also sleeping. And it takes a lot of help from the participant, right? That they have a ton of different equipment and some kind of advanced techniques that we're using, and they have to sleep at the same time. And so at the end of the day, there's this very kind of low-tech limitation that people find it hard to sleep for a long time. And so we were able to kind of do this study and catch these kinds of early phases of sleep, but we weren't able to kind of scan someone over the full night and catch the later stages of sleep.
Okay. And do we know, though, like in terms of quality of sleep, do we know the proportion of what we should get for light, deep, intermediate, or REM, or I have to be honest, now that I have a tracker and I track my sleep, I'm more confused than ever, because I get a little bit of deep, a little bit of REM, a lot of light, and I'm like, is that normal?
Yeah, so keep in mind for those trackers that, the way we really define sleep, we do it purely based on like the electrical activity of the brain. So the trackers are doing the best that they can, but, they're usually using your motion or your heart rate. So they can't really tell you, each little bit of every stage that you have. And so, for example, people who maybe move a lot more during their sleep, that'll kind of throw off some of these potentially as well. For non-rapid eye movement sleep, so non-REM, usually you spend about 70% of it in this intermediate stage, and about 15% in light sleep and 15% in deep sleep. And then REM, you do later in the night. And so that's sort of, usually only in the second half of the night you start to switch into more of this REM sleep. Yeah. Everybody's different too. Sleep is very individualized. There's these lucky people who need very little sleep, and then there's people who need a lot of it, and people have different amounts of these rhythms, and we're still learning, exactly how each of these dynamics relates to that individual's brain function.
Okay, so how many people are you recruiting for this next study? And just to sum it up, what do you hope you know by the end of the study?
So I'm hoping to recruit 60 people. And I would really like for us to know whether and how these waves of fluid are affected in healthy aging, or in people who are, at risk for dementia, or, perhaps, moving towards developing it. And if we could understand, where they're coming from and their functional importance, then I would hope that we would also start to generate some ideas about what we could potentially do to modulate these things, and to, hopefully think about how could we, potentially help in the longer term to address these problems.
Well, it seems that your research should go hand in hand, or another study should be launched about sleep aids and what they do. I mean, because if we do determine that sleep is really good for flushing toxins out of our brain, then, how reliable are taking sleep medications in order to mimic that same process? Because that seems like it could be an easy fix. Not that I'm saying everyone should rush out and pop sleeping pills, because, we know they're addictive and everything, but just wondering, do we believe that, do you believe that by the end of the study, we can conclude maybe that more sleep is beneficial for perhaps one step towards preventing dementia?
It might be. So firstly, I really agree. I think we need to investigate sleep medications. I've previously done a lot of work on anesthesia. And so looking at, different kinds of drugs that modulate states of consciousness and how they alter brain activity. And so I think that, a lot of what we've learned in the case of anesthesia, which is very different from sleep, but it has this kind of controlled pharmaceutical way to induce it, could be used to try and understand what effects the drugs have for sleep.
What was the conclusion with anesthesia?
Oh, we were trying to understand why it is that people lose consciousness during anesthesia. And what we found is that it seems as if different parts of brain networks have trouble communicating with each other. And it's that kind of communication breakdown that seems to be involved. So that's probably quite different than in sleep, where in sleep your brain is trying to kind of strengthen memories and things like that. But in terms of, I'm sorry, what was the second part of your question?
No, I was just wondering how, just sleep aids and dementia, and whether or not,
whether there was like a specific thing.
Yeah.
It might not be that a specific stage of sleep is critical as much as it might be, for example, that specific patterns of brain activity within a stage, right? So during a specific stage of sleep, you will have certain kinds of events, and maybe you could have the same amount of sleep, but a different amount of these events that are happening within that stage. So that's the other thing we have to look at.
Okay, and someone is just asking, what's the age group you're looking for this study? Is there age restriction? I mean, it sounds like you don't want people with diagnosis, but more MCI headed towards that memory loss. Is that right?
Yep, that's right. So we're still in process, so I can't actively recruit for anything right now because we always kind of go through our ethical institutional approval board. So everything is routed through you for recruitment. So I don't recruit on Facebook,
Okay.
but we are planning this study.
So how do people find out when you're ready? How do people find out? Where do they go to find out more about this study?
People are welcome to look at our lab website, which is on the BU Engineering School, and that describes all the kind of research that we're doing and contact information for the lab for people who want to reach out as well.
Great. Thank you so much, Laura. And please come back and tell us. We're, obviously actively interested in this topic. I think whether you're a caregiver or a person diagnosed with dementia, the topic's really important to all of us. And certainly we want to know exactly how sleep relates to our brain health. So please do come back and tell us the results of this study, and we'll be looking for results as well and keeping abreast of your research.
Will do. Thank you. Yes, great to talk with you.
Thanks so much for joining us. Now, for all of these interviews, of course, you could go to beingpatient.com. We are going to post these interviews. We're always looking and actively interested in knowing what topics you want to know about. We have a way to connect directly with the researchers. So please leave us a comment, or you can email us at info@beingpatient.com, and we will cover a topic that you'd like to hear, or interview a researcher for that matter, or an expert you'd like to hear from. So thanks very much for watching, and we'll see you next time.